for what values of x does the series x minus 3 to the n over n converge? This one's looks a little bit different than the last one because of the x minus 3. I have a power series centered at what value? 3, because that's this number, x minus 3. It should be, remember our general form for this is x minus a to the n. So I can now say that this is a power series centered at 3. And so remember, we always know that a series converges where it's centered at. So I know that this converges for x equal to 3. But I want to know all of the values. This one doesn't have a factorial like the last one. It's not a dead giveaway that we should use the ratio test, but pretty much in all of these power series, you're going to use the ratio test. Okay? So let's do that. So I'm going to take the limit an plus 1 over an x minus 3 to the n plus 1 over n plus 1 times, I got to divide by an, so I flip the fraction. All right, ratio test, we group up our like things. So I'm going to group up the x minus 3's, and then my other terms I'm going to group together. So remember, all I'm doing is rearranging my multiplication here. I'm shifting the two terms in the denominator, I'm interchanging them. And always with the ratio test, we want to simplify. What could I simplify?
Can you divide up the ends?
The ends on the second term?
Yeah.
We have to be careful because of this plus 1. If it was flipped, we could divide. But because of this plus 1, we can't divide.
We can pull out an x minus 3 again if you need later.
Yeah. So let's pull out an x minus 3. So if I do that, x minus 3 to the n, x minus 3, x minus 3 to the n. And now I can cancel. The x minus 3's to the n's cancel, and I'm going to be left with x minus 3. Okay. This is the same thing as using your exponent rules where you subtract the powers. N plus 1 minus n leaves you with 1 as your exponent. Okay. And then I have these two things I'm multiplying. I've kind of simplified as much as I can. So now it's time to deal with the absolute value. N over n plus 1. That's positive. So I'm going to leave it alone. And then again, this x minus 3, I don't know if it's positive or negative. It depends on the value of x. So it's forced to stay inside of the absolute value. It has no choice, as it could be a negative number.
So for n's, we know it's going to be positive because it's not like a variable.
No, n, we're taking the limit as n goes to infinity, and remember the n comes from our series. We're plugging in positive numbers for n. But here, x is our variable. X could be any number, and that's why we're not sure if it's positive or negative.
Just leave that up there.
So let's pull out this x minus 3 again. I'm taking the limit as n goes to infinity. So this x minus 3 looks like a constant to my limit, and so I can pull it out in front. Okay. And we want to calculate this limit now. What's the degree of the numerator? 1. Degree of the denominator? 1. They're the same. So limits, when they're the same, all you have to do is take the ratio of their coefficients to get this limit. So this becomes 1 over 1. If it was 2n plus 1 in the denominator, the limit would be 1/2. So I'm left with the absolute value of x minus 3. So we've finished calculating our limit, which means we can go back to our statement of the ratio test. I need that number to be less than 1 in order to converge, okay? So this series converges by the ratio test when this number, absolute value of x minus 3, is less than 1. So now we need to solve an inequality. X minus 3, if the absolute value of x minus 3 is less than 1, this should be a number between -1 and 1. And then you can treat this just like an equation. Add 3, 2. So if x is any number between 2 and 4, I know the series converges. For those values. Okay. And I said 3, our series was centered at 3. 3 is included. It's between 2 and 4. So then we want to know, is this all of the values for which it converges? We're using the ratio test. The nice thing about the ratio test is you can use it whenever you want. And I said there's a payoff, right? There's a consequence. The ratio test is inconclusive when the limit is 1. Okay? So that means I need to check when is this thing equal to 1, and I've got to confirm if that series converges or diverges. So let me say this. Nope. But the ratio test is inconclusive when our limit, which was x minus 3, is equal to 1. When is x, the absolute value of x minus 3 equal to 1? What values of x make that? 4? What else?
Oh, 2.
And 2, right? So you set this equal to -1, and you set it equal to +1, and you solve. X equals 4, and x equals 2. It corresponds to the two endpoints of this interval you've got up here. You've got this interval here. Your two values here correspond to the two ends of your interval. So you've got to check each one of these two values. I got to check x equals 2 and x equals 4 and see if it converges or diverges. So in order to check these, you go back to your original one, my original series, and plug in those values of x. Okay, so I'm going to rewrite my original series. It was n equals 1 to infinity, x minus 3 to the n over n. And I need to plug in both values and see what happens. So let's start with x equals 4 and plug that in. Four minus 3 to the n over n. I need to simplify that. Well, this is really just 1 to the n over n. What's 1 to the n? 1. It's always 1.
Harmonic, so it's diverging.
Yeah. So this is a harmonic series. And so it diverges. Okay? So I know that this x equals 4 is not going to give me something that converges. It gave me something that diverged. I still need to plug in 2. That was my other value. So let's plug in 2 now and see what I get. Two minus 3 to the n over n. Okay, well, I can simplify that. I get -1 to the n over n. You need to know if that converges or diverges, so maybe we need a test. Alternating, it's an alternating series, so you should use alternating series test. So let's do that. My Bn, my positive part, is 1 over n. You need it to be decreasing, so you need, I gotta check two things. 1 over n plus 1, 1 over n. Which one of these is bigger? I'm going to cross multiply. So the one on the right is bigger. So I've showed that this is a decreasing sequence. Check. That was the first thing I need to check. And then the second thing I need to check is that the limit of Bn is 0, which it is. Okay. So time for our conclusion. Alternating series test tells me this series converges. Alternating series test only tells you something converges. So the answer is converges by AST. So when x was 2, it converged. So I need to include the value 2 in my list of all the values where it converges. So this series converges when x is between 2 and 4, but I'm going to include 2 and not include 4. You could also write this in interval notation. How would you write this in interval notation?
Square bracket on 2, comma, parentheses on 4.
Yep. Okay. And that's all of the values where this series converges. That's a complete list. You want to think about it like that.